Hi, I'm back. I now have the camera focused on the light pad, on the light stand, and I have the light turned on, and I have these sheets that polarize the light. And as I said, they have an axis which they through which they transmit the light. If the axis, I have indicated the axis with these arrows. If they're parallel, they have not much of effect because they're both passing the same kind of light. But as you see, if I turn them at a right angle so that the bottom one, the big one, is passing the light that is vertically polarized, but the small one is passing the light that is horizontally polarized, nothing gets through. The horizontal light has been absorbed by the bottom sheet, and there's none of it left to get through the top sheet. And the other one acts just the same. If you have it parallel with a parallel axis, it doesn't have any effect, but as you turn it gradually, it gets darker and darker until it completely extinguishes the light coming through when it's at right angles. And you can have all three of them together. You can investigate the effects of having three of them, but you don't discover anything new. If there are two of them that have crossed axes, then no light gets through. If there are parallel axes, as they are parallel in the case of this one here and the big one, then you get light through the combination, but it's cut off over here, and it's cut off pretty much the same if you have one or you have two of the cross polarizers. Now, so we think we understand this, right? There's two different kinds of light, and if you cut off one of them, then it doesn't get through the other filter. The filters filter out one type of light and let through the other type, and if you make it so that none of it gets through, the two filters are filtering out the two different kinds of light. Well, let's try a different kind of experiment. Let's put one of these filters at an angle. These, if you put at an angle, they gradually extinguish the light. But let's try putting one in the middle between the two at an angle. And lo and behold, we see that now the light is coming through. Even though the bottom one and the top one are crossed, the one in the middle somehow allows some of the light to get through. So it's not quite as simple a situation as we thought. This is a good example of a superposition where the two different, you can use two different bases to analyze the phenomena. You can use vertical and horizontal, but if you use an angle base to analyze the phenomenon, the phenomena then changes. It's now going at an angle, and when it's going at an angle, it can get through the top polarizer. In fact, we could instead of using vertical and horizontal, how about if we do something like this and have a 45-degree angle of one of the sheets, and then if we have another sheet that also is at 45 degrees, nothing happens. But if we turn it so it's crossed, then nothing gets through. But if we have something in the middle that is at an angle, then some gets through. Now, this is a bit of a mystery if you're just thinking in terms of conventional filters, but there is a good way of analyzing it that capitalizes on its quantum nature. It requires a little bit of mathematics, which is what I'm going to talk about. We need some vector mathematics. We need to use the dot product. And then we need to think about some vector spaces and to figure out how to predict this phenomena.